Hi guys, good morning, good afternoon. So this video session is to give you a demo about our Catalyst, TMF Catalyst project, which is a measurement of trust in an AI environment. I'll be walking you through how we have built the framework for measurement of trust and how we have applied this framework on a real world use case, that is churn prediction, and showing you the difference between building a traditional AI system versus building a trustworthy AI system, which has been a core objective of this project. All right, let's get started. So before I jump onto a demo, what I want to do is I want to spend some time to give you a context about what this project is about and why we are doing this project. Okay. So guys, we all know that today AI is reality. It's no more a hype. It has demonstrated its capabilities across different domains, and a lot of enterprises across the world are embracing AI in their day-to-day data-driven decisions and automations, etc. And on the other side, we have seen enterprises embracing AIs. They are putting this digital transformation plans. For example, the CSPs, the communication service providers, are becoming a digital service providers. And AI is expected to play a major role in this transformation. So with this context, now is the moment. While the larger enterprises wants to harness the power of AI, we need to make AI technology more responsible. Hence the need for the measurement of AI trust. Um, but however, while we have seen the great applications of AI, we have also seen AI in been in bad light recently. So today, the strength of AI is its ability to learn from the data as a result of the robust algorithms that we have. However, the underlying data is not always true to the reality. It has its own biasness and it encapsulates the human prejudices. While the algorithms, the machine learning algorithms, are designed to achieve performance, but it comes with a cost of biasness. It comes with a cost of lack of explainability, and as a result, AI systems are vulnerability for safety and security issues. Hence, we have seen certain many AI applications which has miserably failed over time, and this has been a hot topic in the recent media. Well, it has obviously increased the concern of AI being biased and affecting people's trust and wider adoption. Correct. So what we want to do as part of this project is how do we build one AI trust framework which helps us diagnose the biasness, the vulnerabilities of any AI application. And second, how do we equip the enterprises with tool sets which they can use to build trustworthy AI models, but it also helps them to understand what they need to do in order to make any AI system more trustworthy, thereby drive larger trust and adoption in the enterprises. However, this is essentially a very challenging problem, right? Because the trust is multifaceted. It is more psychological aspect than technological. It has the concept of trust is largely influenced by cultural and social elements. Um, so we are attempting to uh, build, identify some of the core fundamental pillars of AI and articulate them on some real world use cases. Now, how are we doing that? So we have conceptualized a framework with our collective experiences with AI products and systems, where we believe that there are four key constructs to which forms trust, right? How reliable you built an AI model is with respect to performance, with respect to its robustness for different kind of issues and challenges in the data. The second aspect is how safer you build the model. Like, of course, you can diagnose the models for known safety issues and concerns, how you can safeguard the models from the external adversarial attacks. So that constitute the safety construct of trust. And third is how transparent you built an AI model, I mean, how much you are familiar and aware of the entire process of machine learning and how the model or algorithms are learning from the data, and when it is needed, will these algorithms be able to provide you with the required explanation? That constitutes a transparency. So once these three broad constructs are in place, we believe it becomes easier for us to take responsibility of these AI systems, because we essentially know when these AI systems are supposed to work, in what situations or scenarios these AI systems tend to fail. So we can back them up with humility rules. We can be accountable for the behavior of AI systems, and it leads a way to build the AI ethics which can be applied in organizations, right? So while we have these four key constructs of trust, these are in turn broken down into various different dimensions. And the idea of identifying these dimensions is that how do we measure these in the entire development life cycle of an AI product, right? So we can look into performance of the models in various different ways, both statistically as well as from the business KPIs. We can look into the fairness aspect of the model on different privileged groups, unprivileged groups, on different variables, on different group of customers, and we can encapsulate that how we want AI to behave for certain section of the society, and we can build explainability, which is a very interesting area in the AI, which is attempting to make the AI algorithms more white box. So how can we create that um, ecosystem in our ecosystem around AI systems with which you can interact and get explanation to various different scenarios, or get an understanding of how AI will behave in certain cases. And lastly, there is a dimension about security. So when will AI system start behaving very strange? What are those scenarios? What are those situations? Proactively identifying those risks. We can put some mitigation strategies. We can put guardrails. We can also assess how vulnerable an AI system is for the adversarial attacks, so that identifying all this at the time of building the AI system gives you an opportunity to monitor the behavior of AI systems when they are in field, and you already have a mitigation strategies to counter that, right? So these dimensions are identified for that purpose. Of course, to really measure these dimensions, to really see whether these dimensions are really um, can be applied to any AI system in general, we have identified various different factors, and these factors are in turn broken down to many different qualitative and quantitative metrics. Here, the idea really is, can we quantify trust? Whenever we build an AI model, can we come up with a number which can tell us that, yes, this is an AI trustworthy AI model, it has a specific score, and we can set some cutoffs and thresholds on that score. And if we don't achieve a specific trust score on any AI model, we can look for the root cause analysis. We can do root cause analysis. We can look for issues. We can see and we can improve upon it, right? So that's the main intention of building a quantitative framework around AI trust. Well, so applying this AI trust framework on some real world use cases. So we wanted to leverage some of the existing TMF artifacts, as you can see on the screen. and then and also see that if there is any opportunity, it provides us to enhance these artifacts, because these artifacts have been built for different aspects of lifecycle management of an AI system. And with these artifacts, we also want to identify, are there any opportunities for us to enhance our framework? But our main intention is to develop the tool sets applying these artifacts, which we can equip to the enterprises to use them on all their AI systems. Okay, so with that, let me directly jump into a use case to illustrate to you how these frameworks are applied on a real world use case, guys. So one of the common use case that we have chosen here, because it's a churn prediction model, because every enterprises has a churn prediction model in some shape and form. And we believe this is most commonly used and also most commonly misused kind of a model. I think we all know the main intention or objective of churn prediction model is we want to develop an AI system which can help us to proactively identify the churn behaviors among our active customers. Now, what might happen in this process is, um, so the AI system can many a times identify the churn behavior which doesn't happen in the reality, and sometimes AI systems can may not identify the churn behavior especially among the high value customers. In both these scenarios, there is a loss of marketing budget in the first case, and in the second case, there is a loss of revenue, right? And third is we will lose an opportunity of a marketing intervention, right? The whole objective is of identifying proactive churners is that so that a marketing intervention happens and then we can retain our high value customers um, as much as we can by providing them either a customized or personalized offers or services, or at least we will have an opportunity to hear out from them what their concerns and issues are and then resolve them in order to retain them. So we felt this is a very good use case, and this will help us identify uh, not only just built an AI model, which is a traditional approach, but we wanted to see that will this kind of a churn prediction model will be biased for certain group of customers, certain type of customers. Can we put together the mitigation strategies around it? Can we seek explanations whenever the AI models gives incorrect predictions, like it predicts churners, but in reality they may not churn, and vice versa. So I think we can come up with all these outcomes on this particular use case. So this use case had a potential for to apply this framework.